Swayam Prabha. Digital India. Educated India.
Hello everybody. Today we are going to learn bilirubin formation. We will learn this topic under what is bilirubin, how it is formed, what is its fate. In general, RBC lifespan is approximately 120 days. These old RBCs are removed from the circulation by macrophages present in liver, spleen and bone marrow. These macrophages degrade the RBC and release hemoglobin into the circulation. In human adults, 1 to 2 into 10 to the power 8 erythrocytes are destroyed per hour. In this, 85% are old RBCs and nearly 10 to 15% are defective newly formed erythrocytes. Approximately 6 grams of hemoglobin turnover per day takes place in an adult individual. And other hemoproteins also have heme as similar to hemoglobin, and breakdown of this heme result in formation of bilirubin. Ultimately, bilirubin is formed from heme. Then what is heme? Heme is porphyrin ring. These porphyrin rings are cyclic compounds formed by fusion of 4 pyrrole rings linked by methynyl bridges. These are the 4 pyrrole rings: ring A, ring B, ring C and ring D. This also named as pyrrole ring 1, pyrrole ring 2, pyrrole ring 3 as well as pyrrole ring 4 instead of A, B, C, D and D. And these methylene bridges are alpha, beta, gamma and delta. An atom of iron present in the center as Fe2 plus. So, this together called as ferroprotoporphyrin. So, heme is a ferroprotoporphyrin. So, once heme is released from the hemoglobin as well as heme proteins, the degradation of heme takes place. The catabolism of heme from all proteins, all heme proteins takes place in microsomal fractions of cells by a complex enzyme system called as heme oxygenase. By the time the heme is derived from the heme proteins reaches the oxygenase system, the iron usually been oxidized to ferric form. See, in the heme the iron is present in Fe2 plus, but here when it is reaches to oxygen and oxygenase system, it becomes ferric form and it is called as hemine. Porphyrin ring with Fe3 plus called as hemine. Forming biliverdin is the first step of formation of bilirubin. So, with the aid of NADPH and oxygen, the ferrous ion became ferric ion and release. See, because using NADPH, first this ferric ion forms ferrous ion, heme, then that ferrous ion again become ferric ion and released. Along with this the methynyl bridge, that is the alpha methynyl bridge, I have shown the alpha bridge, the carbon between the rings A and B is released as carbon monoxide, and equimolar quantity of biliverdin also released. So, this will learn here. This is heme proteins, examples hemoglobin, this is from the RBC as well as the reticulocytes, and myoglobin, other protein present in the muscle as a oxygen carrier, cytochromes present in all cells. These all are heme proteins, and heme is a part of these these are conjugated proteins, and heme is a prosthetic group of this protein. When they reach macrophages, there first heme is separated from the globin or protein part. This protein part undergo degradation and gives amino acids which enter amino acid pool. So, macrophages first convert heme proteins into protein and heme part. So, here you see the heme is here, protein is here, and protein becomes amino acid. It is a monomers and enters the amino acid pool. This protein cannot be reused directly, so it has to degrade to amino acids and utilize for the further synthesis of new protein. Now, fate of heme is the heme oxygenase acts on this heme. So, it will open first this Fe2 plus become Fe3 plus, that is a ferric form. So, when it is Fe3 plus, this molecule called as hemine. Then one more NADPH attached here, this is a alpha bridge, this is a pyrrole ring or a first pyrrole ring of a structure, and this is a second one. So, between 1 and 2 or A and B, this methylene bridge is takes NADPH and oxygen and releases NADP and carbon monoxide. This carbon is released as carbon monoxide, and this hydrogens and oxygen added to these two carbons. And Fe3 plus, that time the changes happens in the Fe2 plus become Fe3 plus and released, which is utilized for next synthesis of taken up by the transferrin, transported to where it has to be stored or reutilized, and the product is formed is biliverdin. It is a green color pigment. It is opened in first and second pyrrole ring in the porphyrin, and this is a green color pigment. In amphibians as well as the birds, this biliverdin is excreted as biliverdin itself as a green pigments, but in human beings this will convert it to bilirubin. So, this is a biliverdin, and the conversion to bilirubin by the enzyme called as biliverdin reductase. Since reductase is there, reducing the methylene bridges between third and fourth ring or C and D ring, we need the hydrogen ion that is taken up from NADPH. So, NADPH donate the hydrogen ions to this methylene bridge, and methylene bridge reduced to methyl bridge between 2, and this is the structure of bilirubin, and bilirubin is a reddish orange color pigment. This is a green one, this is a reddish orange color pigment. This pigment is water insoluble, and this pigment do not have any function in our body. So, it has to be excreted from the, since it is a water insoluble and no function, so it has to excrete it from our body. The liver is the main organ which do the detoxification processes. Detoxification means toxic compound. See, since bilirubin is a water insoluble, so it is a toxic to our body, and it has to made more water soluble and it has to be excreted. This process takes place in the liver, but from the formation it has to taken to the liver by binding to albumin or any protein. When lipophilic compounds bound to protein, they become more water soluble. So, it is estimated that approximately 1 gram of hemoglobin yields 35 milligram of bilirubin, and we learned that nearly 6 gram of hemoglobin turnover happens per day. So, 1 gram gives the 35 milligram of bilirubin. So, 6 gram can give nearly about 250 to 350 milligram of bilirubin per day. In this, the majority of the heme comes from hemoglobin, that is 85% of old RBCs. They finish their lifespan and it has to be removed from the circulation. Macrophages will release this hemoglobin from the RBCs. Other than this, we also have defective reticulocytes or immature reticulocytes. These are coming from the bone marrow. Nearly approximately 10 to 15% of reticulocytes will get degraded and release hemoglobin. Along with this, there are many other proteins called as heme proteins, such as cytochrome P40 as well as myoglobin, all those things. They are nearly 10% also release heme into the macrophages. So, together 6 to 7 gram of heme will be hemoglobin will be converted to bilirubin. This bilirubin formed in the reticuloendothelial cells is insoluble in water. So, this reticuloendothelial cells, in the sense macrophages as this system, there bilirubin is formed and this is a water insoluble compounds. So, then they are toxic. So, this lipophilic bilirubin is therefore transported in plasma by binding to non-covalently to albumin. Albumin is a plasma protein. Since lipophilic bilirubin binds to albumin, that makes it more water soluble, but the binding is non-covalently binding, means it can be release it easily. So, one molecule of albumin can bind 2 molecules of bilirubin. So, here albumin has, it means albumin has 2 binding sites for the bilirubin. In this, one site is have a more affinity towards the bilirubin, the other site has a least affinity. So, 100 ml of plasma can transport up to 25 milligram of bilirubin. So, this is very important. So, most of the time all the bilirubin bind to the more affinity site, not low affinity site. Some drugs, certain drugs such as salicylates, sulfonamides can displace this bilirubin from albumin. So, permitting, and this also permitting the bilirubin to enter the central nervous system. Since bilirubin binds to albumin non-covalently, so these anionic drugs can replace them. When in the case of infants, this can cause neural damage. So, this information suggests that whenever there is a treatment for the infants for hyperbilirubinemia, so we have to take care that the drugs whichever given can replace bilirubin from the albumin and enter permit the bilirubin to enter the central nervous system. The further metabolism of bilirubin occurs primarily in the liver. As I said, liver is an organ present in our body, do all the detoxification reactions, processes, and it can secrete or excrete the detoxified compounds through the bile as well as through the systemic circulation. So, this bilirubin is excreted from the bile. So, it can be divided into 3 processes. There are 3 processes there for the conversion of the bilirubin to more water soluble and excreted from the body. The first process, when the bilirubin comes bound to albumin near the liver cells, uptake of the bilirubin done by the liver parenchymal cell. So, liver parenchymal sinusoidal site of liver parenchymal site, the bilirubin is taken up by the liver, and there we have other proteins, they bind to bilirubin, and bilirubin will be utilized for the further metabolism. The second is conjugation of the bilirubin with the glucuronic acid or glucuronate in the endoplasmic reticulum. So, this can be done by the enzyme called as glucuronyl transferase. So, the glucuronic acid as a active glucuronic acid, UDP glucuronate will donate glucuronic acid glucuronate to bilirubin, and bilirubin forms diglucuronyl bilirubin monoglucuronate as well as bilirubin diglucuronate and become more water soluble. The third is the secretion of this conjugated bilirubin into the bile. So, conjugated means monoglucuronide as well as bilirubin diglucuronide has to be secreted into the bile. So, from this this bile will goes to the gallbladder, there it gets stored, and from there it enters the duodenum. So, in the duodenum it when it reaches the large intestine. So, duodenum is part of small intestine. From there this bile enters the small intestine. From there it goes to the large intestine. There this bilirubin get modified first by the bacterial flora. So, these bacterial enzymes first convert bilirubinic glucuronide to free bilirubin, means deconjugation happens, and this bilirubin becomes not biliverdin, it is become urobilinogen, and urobilinogen becomes stercobilinogen and excreted through the feces. This bilirubin is yellow orange pigment, and bilirubin become urobilinogen is a colorless pigment first, then this colorless pigment becomes stercobilinogen by bacterial flora, which is a brown color pigment. So, this gives the classic color to our stools. So, summary, like heme proteins when reaches the macrophages, their endoplasmic reticulum of this macrophages cell will convert heme to heme protein to heme plus protein part. This heme part will be converted to biliverdin by the enzyme called as heme oxygenase by releasing one carbon monoxide molecule and utilization of 2 NADPH plus H plus. So, this is only one reaction present in our body which produces carbon monoxide. This bilirubin is immediately converted to bilirubin by the enzyme called as biliverdin reductase, and it utilizes the NADPH plus H plus as the hydrogen source. This bilirubin bound to albumin taken to the liver, and liver will take this bilirubin from the albumin, conjugate it with glucuronic acid, forms bilirubin monoglucuronide or bilirubin diglucuronide, and then excreted into the bile. So, from this bile duct enters the small intestine, when from the small intestine it passed to the large intestine, or at the end of the small intestine and beginning of the large intestine, there the bacterial enzymes remove the glucuronic acid from the bilirubin monoglucuronide as well as diglucuronide. So, this bilirubin is converted to first urobilinogen, and this urobilinogen is a colorless compound, becomes stercobilinogen, then it is excreted in the feces. Little part of this urobilinogen also absorbed, nearly 5% absorbed in the enterohepatic circulation, it means it absorbed in the portal system and taken to the liver and resecreted into the bile, and that comes to the intestine. So, urobilinogen get absorbed and resecreted into the intestine is called as enterohepatic circulation. And little amount of this whatever reabsorbed 5% also enters the systemic circulation, that enters the kidney and gives the color to the urine. This is a summary of this thing. Thank you very much.